The concept of a gradient is very important in physiology. And a concentration gradient is the difference in concentration between two locations. So if we have a situation separated by a membrane, we have a concentration on one side, compared to another side, there is a concentration, and let's call this side A, side B. So the concentration gradient would be B minus A concentrations. So that's the concentration gradient. Now the concentration gradient of the solute will determine the osmotic gradient and therefore the movement of water. And what we're going to have then is, let's pick side A. And we know that the initial volume times the initial concentration will equal the final volume times the final concentration, because moles equals moles. Solving for the final, right there, will equal the initial concentration on that side divided by the final concentration times the initial volume. In this case, the initial concentration is less than the final concentration on side A, because water is going to leave side A, therefore making it more concentrated. And it's a semi-permeable membrane, so the solute cannot move. So because of that, Ci, or initial, over C final is less than 1. Something less than 1 times anything will make it less. So therefore, the final concentration on side A will be less than the initial concentration. And it will be scaled according to this ratio of the initial over the final concentration. Now that final concentration is going to be somewhere in between 3 and 6. And indeed, it's going to be 6 plus 3 divided by 2. It's going to be the average of the two, because we have free movement of water. So that's 9 divided by 2. And so 9 divided by 2 will be the final concentration. The initial concentration was 3, so we have 3 divided by 9 divided by 2 is 4.5 times the initial volume, whatever it is, and therefore we have the final volume.